In this video, we're going to have a look at how to use the quadratic formula to solve quadratic equations. So the questions we're looking at are from the Cambridge 11 Maths B textbook, exercise 1C, and specifically we're going to be looking at question 4 onwards. So remember, as we've looked through exercise 1C, we've been looking at different ways to solve quadratic equations. So that's an equation which has a x squared in it, or the variable is squared. That's how you know it's a quadratic. Okay, some methods we've looked at so far are isolating x, so finding x algebraically by rearranging or transposing the equation to isolate x, similarly to what we did with linear equations. You've become really skillful at factorizing, which is what you did in question 2. We had a look in class at completing the square, and now we're going to look at using the quadratic formula. So there are lots of different methods you can use. As you become more experienced, you'll be able to make a good judgment about which one to use in which situation. That you should get the same answer each way, provided you've done it correctly. But the good thing about the quadratic formula is it's an efficient way of solving the quadratic equation, and you know that it's going to work even if the other methods don't work. So if you find factorizing a little bit difficult, or you get stuck on how to factorize, you know that the quadratic formula is going to work. Okay, so we're looking at question 4 of 1C. First of all, let's just pick apart the quadratic equation a little bit. So the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now there's a lot going on here, so we're just going to break it down a little bit. First of all, think back to when we learnt about the quadratic form of an equation, which looks like this: ax squared plus bx plus c. Okay, you know an equation is quadratic if it's in this form. Sometimes the numbers could be in different order, like the c could be first, or the ax squared could be last, or whatever, but you always know that there's going to be an x squared, an x, and then a constant value as well. Or the constant value might be 0. So if, for example, it just said ax squared plus bx, the c is still there, it's just not written because it's 0. Okay, now the important thing to remember here is that when you're thinking about the coefficients or the variables a, b, and c, a refers just to the number that appears before x squared, not the entire number there, ax squared. So for example, if you're looking at an equation like 3x squared minus 2x plus 1, just as an example, if I said, what is a in this equation, you wouldn't say 3x squared, it would just be 3. Okay, a equals 3. B, in this case, is 2, but it's not just 2, it's actually negative 2, because the sign in front of that coefficient belongs to it. So the answer for what is b would be negative 2. And c, in this case, is 1. Okay, so a, b, and c are just the coefficients. Okay, that's going to take me a while to erase. All right, so coming back to our quadratic equation. Let's just break this down a little bit. So first of all, we've got negative b here, negative b. Oops, negative b. Okay, so whatever b is, you're going to put it in here with a negative sign in front of it. So if it's a positive, it becomes a negative. If b was a negative, the two negatives would cancel out and you'd be left with a positive. Okay, now the plus or minus means that you're going to have two solutions for this problem. And that's because recall that when you have a square root could be a positive or negative number if it isn't specified which one is being referred to. For example, if you were talking about 25, the square root of 25, that could be positive 5 or negative 5, because both of those numbers squared would give you 25. Okay, then we've got the square root sign, and the b squared minus 4ac all goes under that square root sign, the whole thing. Okay, so when you're putting that in your calculator, don't forget that you may need to put brackets around that if your calculator doesn't show it all going under the square root sign. Okay, here we've got b squared which means, again, if b is a negative number, squaring it is going to give you the positive version of that. Minus 4 times a times c. Remember your order of operations here. You would do b squared first minus the results of 4 times a times c all over 2 times a. Okay, it looks a little bit complicated, but once we put some numbers in there, you're going to see how quick and simple it is to use. So I'm going to do now for you question 4. Where are we? Okay, question 4a, solving for x using the quadratic formula. So the equation we're trying to solve for is 2x squared plus 5x plus 3 equals 0. Now this 0 here is really important. Always check that the equation does equal 0 before you start trying to solve it, either by factorizing or using the quadratic equation, because you won't get an accurate answer if it doesn't equal 0. It won't be true for x. So if you do have a number there, you need to bring it over to the left-hand side of the equation so that it equals 0. Okay, but in this case we're fine. The first thing I'm going to go through and do is identify our numbers a, b, and c. Okay, so there they are. 2 is a, 5 is b, and 3 is c. All right, now I'm going to write out the quadratic equation. It's a good idea to always write it out first, just so we know you're using it correctly and to avoid making any silly little mistakes. All right, now I'm going to rewrite it, putting those numbers in, a, b, and c. Okay, so equals, firstly we've got negative b. b is 5, so it's going to be negative 5. Plus or minus the square root of b squared, or 5 squared, minus 4ac. I've put an open bracket there, so 4 times a, which is 2, times c, which is 3. Okay, and all of that is under the square root sign. On top of 2a, and a in this case is 2, so 2 times 2. Okay, so you'll notice that I haven't actually simplified anything yet. I only substituted the numbers in. It's a good idea to do that first, just to make sure that you're substituting in correctly before you go solving anything. Okay, so now let's take it a step further. That equals negative 5, again, plus or minus the square root of 5 squared, which is 25, minus 4 times 2 times 3, so 4 times 2 is 8, which times 3 is 24, over 4. We can simplify that even further, because negative 5 plus or minus the square root of 1, which is just 1, so the square root sign is actually kind of redundant there, over 4. Okay, now really you could have put this in your calculator at this early stage and solved for that and got the correct answer. It's totally up to you whether you want to continue to simplify and simplify, depending on possibly how confident you are with your calculator, how sophisticated your calculator is in terms of inputting fractions and square root symbols and things like that. So that's up to you. If it were me, I would like to just put it in this initial form, because the more steps I do, the more likelihood there is of making an error. But in this case, I'd like to show you how you could simplify it if you chose to do that. Remember that your order of operations are really important here. So I did the b squared first, and then minus the results of 4 times a times c, etc., etc. Okay, now here we actually have 2 separate equations, because don't forget we have here this plus or minus sign. So that means x can either equal negative 5 plus 1 over 4 or negative 5 minus 1 over 4. Okay, 2 different results. So if x equals negative 5 plus 1, I just wrote 1 instead of square root of 1 because it's the same thing, over 4, then we have the result negative 1.5. Okay? Or x could equal negative 5 minus 1 over 4. Oops, I've done the wrong thing over here. That should be the negative 1.5. This one is not negative 1.5 because we have negative 5 plus 1, that's negative 4 over 4, which equals negative 1. Okay? My apologies. So we've got two possible answers for x. X equals negative 1 or x equals negative 1.5. Okay? Why do we have two answers for x? Remember what a quadratic equation looks like. Okay? Even if you don't know how to graph these yet, keep in mind what we're actually trying to find here. So we have a parabola. Now, I don't really know what this looks like yet, and I don't necessarily need to know what it looks like, but a parabola could look like this, or it could look like this. You don't know yet at this stage what this parabola is going to look like because you haven't got the skills yet to graph it, but we know that a parabola has two x-intercepts, usually, because that's where it cuts through the x-axis. And that's why x could have two different values here. Remember, right up the very top, I told you to make sure that the quadratic equation was equal to 0. That means that we're trying to find the values for x where y equals 0. Or in other words, the x-intercept. Because at these little green points that I just drew on, y does equal 0. Okay, we're not going up or down the y-axis, we're just at 0 on the x-axis. And these are the points where it cuts through. Okay, so that's what we've just found there, x-intercepts. Let's do another example. Let's do question 4c. And 4c says x squared minus x minus 33 equals 0. Okay, now this question is different from the last question in two ways. First of all, there are no values written for a and b. Although that's not entirely true, because remember that if there is no coefficient given, the coefficient is actually 1. Okay, 1x squared minus 1x. But we don't actually write that in. That's just convention. But we do have values for a and b there. They're just not written. But we know that they are 1. Okay, the other thing that's different is that we have negatives here. And that's going to affect how we use the quadratic equation. Not a lot, but you just have to be a little bit more careful with it. So again, I'm just going to write out what my values are for a, b, and c. I've checked that the equation equals 0, and it's in order. So I know that a, b, and c are going to be in order as well. So a here equals 1, which would be there. B is 1, but it's actually negative 1, okay? Because don't forget that that negative sign belongs to the 1. B is negative 1, and C is negative 33. Okay, good. Now I can go ahead and use the quadratic equation. Okay, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Even if you know it off by heart and you're really confident with it, still write it out before you begin. Just good practice. Okay, now we're going to substitute in those values. Now, we've firstly got negative b. B is negative 1. Negative b, so negative, negative 1. Okay, you can write a double negative, that's fine. But in practice, that's actually just going to be positive. So you could write negative, negative 1, or you could just write positive 1. Means the same thing in this case. Okay, plus or minus negative 1 squared. The reason I wrote the negative 1 in brackets is because negative 1 times negative 1 gives you positive 1 because a negative times a negative is a positive. Sometimes if you type -1 squared into your calculator, it doesn't know whether you're doing the 1 squared and then negative of that or -1 times itself. So it's just good to specify and say that it's -1 times -1. Okay, so that would be the correct way to do that. Minus 4ac 4 times 1 times -33. Okay, that's all under the square root sign, over 2 times 1. Okay, I'm not going to simplify this one like I did in the last question. I'm just going to put it all into my calculator to get the answers, and what I'm left with is x equals either 6.27 or -5.27. So as I said, I prefer to just put that all in my calculator and get one answer straight away rather than simplify with several steps, because I find it reduces error by reducing the number of steps you take. Okay, if you just input that into your calculator really carefully and check it a couple of times, it takes less time than stepping it out again and again and again. But of course, you're more than welcome to do that if it makes more sense to you. Okay. Now let's look at a modeling and problem solving example. So I'm just coming back to the textbook here. If we look down at question number 9 here, it says the height h reached by a projectile after t seconds traveling vertically upwards is given the formula h equals 70t minus 16t squared. Okay, so calculate t if h is 76 meters, or in other words, calculate the times where the projectile is likely to be at the height of 76 meters. So think about a projectile. Where am I? Think about a projectile. It says it's traveling upwards, but you can use some common sense to figure out that it's going to go up, oops, it's going to go up and then eventually come back down. Okay, probably a little bit nicer than that, forgive my drawing, but the projectile will come down at some point. So if you think of this as being on a graph, the question asks what time will the projectile be at the height 76 meters? Okay, so it'll be at 76 meters at 2 times. It will have an initial height of 76 meters, it'll probably go up a little bit and then come back down and once again be at 76 meters. So that's all we're trying to find. The worded questions can be a little bit more complicated because you have to tease out the relevant numbers and decide where they go in the equation. But if you can visualize it by drawing a diagram, that will always help you. Okay, so the question says the initial equation given to us is, h equals 70t minus 16t squared. Now, and we want to find t when h equals 76 meters. Okay, we're finding the time when the projectile is 76 meters in the air. So the first thing I'm going to do is substitute h for 76. Now I'm going to rearrange it so that it looks like a quadratic equation, which means it will equal 0 and all of the terms will be on one side. Okay, so that's going to look like this. Okay, if you need some help rearranging equations, have a look at the last video I posted. But what I did here was just take the 16t squared from the right hand to the left hand side by adding 16t squared to both sides. And then same with the 70t, I minused or subtracted 70t from both sides, which gave us all of the terms in the quadratic over on the left hand side, and we're left with a result of 0 on the right hand side. Now this is in a nice form that we can use for a quadratic equation. So remember, the quadratic equation is ax squared plus bx plus c. In this case, we have A equals 16, B equals negative 70, and C equals 76. And now it's just as simple as putting those numbers into the quadratic equation. So again, rewrite the quadratic equation. You'll probably use this so often that you don't even have to go to any extra effort to memorize it. Okay, there it is. Let's rewrite it, plugging those numbers in. So x equals negative b. B is negative 70. You could write negative 70. I'm just going to write 70 because the two negatives cancel each other out and you're left with a positive. Okay, so 70 plus or minus negative 70 squared. Now again, negative 70 squared is the same as 70 squared. So I'm actually going to just write 70 squared. Okay, that's up to you. You're not correct or incorrect either way. You're just using your judgment there. So, and then minus 4ac. 4 times 16 times 76. Again, pay attention to where the brackets go in this equation because you don't want to make a calculator error. Okay, so over 2a or 2 times 16. All right, again, you can simplify that if you want to. I'm just going to go ahead and put it straight into my calculator. And what I get are two results, one for the positive and one for the negative. So my first result is x equals 2. And the second result is x equals 2.375. Now, let's go back to our original question and figure out what those numbers actually mean. The question says, we're trying to find the height, the time when the projectile is at a particular height, and that's time given to us in seconds. So what these actually represent are seconds. In other words, the projectile is at a height of 76 meters after 2 seconds and after 2.375 seconds. That's a pretty sharp turnaround. Now, I've actually graphed this using an online graphing tool. You can see that over here. And I'll zoom out to show you what that entire parabola looks like. It almost doesn't really fit on the screen. There you go. So as I said, it's a pretty sharp turnaround. Notice that the equation actually does go down below 0. In real life, that wouldn't happen because we're talking about a projectile and 0 is at the ground level. So unless the projectile is somehow going underground, we would actually restrict that domain there to not going below 0. All right, now let's have a look up here. We were trying to find the height, the time when the height of the projectile is 76 meters. It looks like, looking at the x-axis of this graph, the y-axis rather, that it actually doesn't go too far above 76 meters. Its highest point is around here. At 76.563 meters, okay? And then that's its highest point, after which it turns around and starts falling back to the ground. 76, you can see over here on the y-axis, that's 76 meters in the air. If we go over here, we can see that the x-coordinate for that is 2. We found that using the quadratic formula, that after 2 seconds, the projectile is at a height of 76 meters. Now the projectile goes up and then comes back down again and is once again at 76 meters at approximately 2.375 seconds, proving what we just found. Okay, so again, if you have a modelling and problem-solving question, always try to graph it if you can. If you have access to a graphing calculator or an online graphing tool, use that. And then what you should also do is answer the problem in words, in terms of the question. So you would take this one step further and actually say that the projectile is at a height of 76 meters after 2 seconds and again after 2.375 seconds. And that's how you use the quadratic formula.